At the turn of last century, we're talking about the 1800s now, there was a German physicist that invented a technology, or a technique if you will, of applied physics called light scattering. Meaning that if you put a light on an object, you can get a predicted pattern scattered off that object.
We use the principles of light scattering to do an identification. And how we do that is we use a laser, and we have a vial that has the contamination in it, and we have detectors all around that vial. When the laser beam intersects a bug, it generates a light scattering pattern that is collected by all those detectors. We take that signal and transform that into a signature.
And the laser actually penetrates the bacteria, so the light scattering we get is a combination of the internal and external part of the bacteria.
And that's how we can identify the bug. So in our labs, we literally run hundreds of thousands of the same species through our system to capture all the sizes, shapes, morphology of the bug, put that in a database, and then during operation, we just do a comparison. So we're not using any additives, chemicals, reagents that are done in all of the other rapid microbial systems today. So that's why our costs are so cheap, like 10 cents per test, versus even other rapid microbial systems that are anywhere between $2 and $45 per test.
We've proven in the laboratory tests that we can identify the most rampant pathogenic bacteria in minutes at cost of pennies.
We know that in the US alone, 325,000 contamination events occur annually and 5,000 deaths. So any impact we can make on those numbers would be a success. Microidentification Technologies has developed a product that we believe will prevent contaminated food from ever reaching the consumer.
What we've been talking about is saving lives in the thousands, saving dollars in the millions with a product that's simple to use. It's been evaluated by the best laboratories in the world and has an immense application.
Well, food safety has been our target primarily because it's not regulated, so it's the easiest place to enter the market, plus the fact it's a huge market, about a $3 billion market. From that, we'll branch off into clinical diagnostics, pharmaceutical, semiconductor, and drinking water. And when we add all those markets together, it's about a $6 billion market.
Very, very simple to use. The key is our little vial, clean water, and the sample that you take. You put it in there, a technician pushes a button, in 3 to 5 minutes, our system will tell you what the bacteria is.
We are an easy product to use. We train someone in less than a half a day as to how to use it. We have an excellent management team that has over 100 years of experience. All of us have brought companies to market in the past.
Then you've got the overall cost of our system. The hardware is significantly cheaper than most other products on the marketplace. And the ease of use has got to be important. You don't have to have a highly skilled microbiologist to be running your laboratory.
When we went to high school, the way we understood how to identify bacteria is we were in our lab and we did a culture in a petri dish, and then we looked under the microscope and we said, okay, that's E. coli. And that's, believe it or not, that's still the way most of the detection and identification is done today. That process is well over 100 years old. It's very slow and very costly and takes a trained microbiologist to be able to make that claim.
It's a matter of getting it out and getting people trained, because it is a brand new technology, a brand new patented technology. And I don't know of anyone that has taken applied physics and used this approach. So, it's a new thing, it has to be supported, it has to be sold.